think that one of the interesting things about a building like this, and any net zero energy building, is we don't know actually if the building's going to be net zero energy while we're designing it, because we'll use an energy model. We'll simulate the building. We'll create a set of assumptions about how people are going to use the building, what kind of equipment's going to be in the building. They're going to use laptops or tower computers, or they're going to use a lot of lab equipment or not very much lab equipment. So we make a set of assumptions, and then we size the photovoltaic system appropriately. And sometimes we say to the owner, oversize the photovoltaic system so that, in case we were wrong. In this building, we didn't have the luxury of oversizing the photovoltaic system. We filled up the roof and then some. Laboratory buildings, the process load, the plug load, is already a very high portion of the energy use of the building. And when we started putting together the pie chart of energy consumption for the building, it was already a high number. It was in the 40% plus range. When we took the HVAC and the lighting energy down, that plug load, process load, became larger and larger percent of the overall energy use of the building. And this is something, a reoccurring theme that we've seen in so many buildings that we've been working on that are very efficient or net zero energy. So we early on started talking to the folks at the Venture Institute about plug loads being a really important part of achieving the net zero goal for this building. So there's no way that we can make net zero without the plug loads being addressed. And so the folks at Venture started by doing it during the design, a wide variety of testing, studying, measuring of their plug loads in their facility in Maryland.
Probably the single biggest thing, and I think this is really important because we've taken this message and our lesson to a lot of our other clients, the single biggest savings in energy was, rather than taking a typical watts per square foot that our lab planners would give us for what we thought the building needed to have, we went and measured their existing labs, both in Rockville, Maryland, and their temporary labs in San Diego. And that, it turned out, when you find out what you really use versus what you designed to, the savings there was probably the single biggest savings in terms of energy, and it didn't cost anything to do that.
When they started filling up the labs here, there was a lot of thought that went into, well, what equipment do we have, and are there ways to make that more efficient? So one of the examples is one of the largest energy users for plugs in a lab are freezers that are used to store specimens. And they typically store these, do the storage at minus 80 degrees Celsius. So it's very, very cold.
And the lower you go in those temperature ranges, the more compression of the refrigerant is needed to maintain that cold environment. So what we did here is we basically changed their user habits, because most scientists, they want to work on their bench and then they turn and they want to store it in the freezer that's right there in their lab. What we did here is we said, well, we're not going to allow that, because if you open most of those freezers, 1 or 2 shelves are full and this freezer is running all the time. So we said what we're going to want to do is co-locate all those freezers into one room, typically called a freezer farm, and that way all that heat, all that noise is confined into one space and it's not in the lab, so it's not affecting the lab load, but then it allows us to treat that room differently. And so what we did is the Venture folks went out and purchased the water-cooled minus 80s freezers. And so there, instead of like your refrigerator at home where you feel the heat coming off the backside, all that heat is captured by the water system. So that same thermal energy system that we're using to cool the building with, we also use that water to pull the heat away from that freezer farm. And in that way we can just have a simple low air volume system in there, because all the heat from the refrigerators actually never gets into the room. It's captured by the water and taken to the tanks.
Another thing in the laboratory is there's a series of plugs. Some are red, some are green, and some are gray. And the gray is a normal plug. The green is a plug that's on a schedule, and at nighttime it will turn off. And then the red plugs are ones that have backup power. So if you emergency power, generator power. So you have something that's very critical, you can plug it into that one. The majority of the plugs are the green plugs. And most everybody is using, I was walking through the lab earlier today, and it looked like more than half of the equipment was plugged into the green plugs. And so at nighttime, those automatically go off. In the morning, they come back on. So the scientists decide, this piece of equipment, it's fine if it's off at night. That alone can save a lot. There hasn't been a lot of thought about the nighttime consumption of laboratory equipment, or the off consumption. The vampire loads is what we call it.
Because a lot of equipment, even in standby mode, has a high energy draw. You'll be shocked. Like a typical copier can be 80% of the running load because people want to make their copies real quick. So by turning that off, we just make sure that we don't impose that electrical demand on the building.
So we can't make an aspirational net zero energy building, laboratory building, without participation from the scientists. Now, not every scientist needs to be distracted by this issue, but some need to say, yes, it's okay, that piece of equipment we can turn off, and so that a culture develops in the laboratory that, of course, we do it that way. And when we buy new pieces of equipment, the purchasing people know about that. Scientists don't need to be distracted. So we didn't want to set up a thing where everybody had to really spend a lot of time thinking about it. They've got a lot of other things they're thinking about and inventing and innovating and everything. So we tried to set it up in a way that was relatively easy for them to participate in.